Good morning, sir. My name is M. Karthik. I am from EC department. Today, my topic is about principle and applications of NMR spectroscopy. Principle and application of NMR spectroscopy. Introduction to NMR spectroscopy. NMR, nuclear magnetic resonance spectroscopy, is a powerful analytical technique used to study the structures and dynamic of molecules. It relies on the interaction of magnetic nuclei with an external magnetic field and radio frequency radiation. NMR spectroscopy is non-destructive and provides detailed information about the chemical environment of atoms in samples. Principle of NMR spectroscopy. When a sample is placed in a magnetic field, the nuclei align with the field and absorb energy when subjected to radio frequency radiation. The absorbed energy causes the nuclei to transition between energy states, emitting signals that are detected and analyzed. The frequency at which the nuclei resonate is influenced by the local chemical environment, allowing for structural determination. NMR instrumentation. NMR spectrometers consist of a powerful magnet to create a stable magnetic field, a radio frequency transmitter to deliver pulses, and a detector to record signals. As the sample is placed in a probe within the magnet and data is collected and processed by a computer. Different types of NMR experiments can be conducted based on the desired information, such as 1D or 2D NMR spectroscopy. Chemical shift in NMR spectroscopy. Chemical shift is the displacement of NMR signal in the frequency domain due to the electrons distribution around a nucleus. It is measured in part millions ppm relative to a reference compounds TMS tetramethylcycline. Chemical shift value provide information about the chemical environment and connectivity of atom in a molecules. Coupling in NMR spectrometers. Coupling occurs when nuclei interact with nearby nuclei through bonds, resulting in the splitting of NMR signals into multiplets. Coupling constant represent the strength of these interactions and provide information about the connectivity of atoms. Analysis of coupling pattern can elucidate the number of neighboring atoms and their chemical environments. Application of NMR spectroscopy in chemistry. NMR spectroscopy is widely used in organic chemistry for structure determination, stereochemistry analysis, and reaction monitoring. It is also available in paracetamol research for drug development, quality control, and metabolite identification. NMR spectroscopy plays a crucial role in biochemistry, material science, and environmental analysis. Application of NMR spectroscopy in biology. In biological research, NMR spectroscopy is employed to study protein structure, dynamic, and interactions. It can reveal information about ligand binding, enzyme mechanism, and conformational changes in biomolecules. NMR is essential in structure biology, drug discovery, and understanding disease mechanism at the molecular level. Solid state NMR spectroscopy. Solid state NMR is used to study materials with limited molecular motion, such as crystals, polymers, and membrane proteins. It provides insights into molecular structure, phase transition, and molecular interactions in solid sample. Solid state NMR is valuable in material science, zoology, and parasitical formalizations. Advance in NMR spectroscopy. Recent advancements in NMR technology include higher magnetic field strengths, cryogenic probes, and dynamic nuclear polarization. Solid state NMR techniques such as good angle spinning and multidimensional experiments have expanded the applications of NMR. Integration of NMR with other analytical techniques such as mass spectrometer and X-ray crystallography enhance the information obtained from complex samples. Conclusion and future perspectives. NMR spectroscopy is a versatile tool for studying molecular structures, dynamics, and interaction in various fields of science. Continued developments in NMR instrumentation and methodology will further expand its application and capability. The combination of NMR with computations, modeling, and other analytical techniques holds promise for addressing complex scientific challenges in the future. Thank you, sir.